Okay, just wanted to make sure on this. Um, so we already set the warm start. So the idea is that then when you set the parameters, okay, because you're setting it on top of the RF that you've already like initialized and scored that has the warm start set. When you run this in estimators equals say 50, the next number, it's going to use the previous 25 as a starting point and keep going. Okay. So if we run this code, then um, and oh because I was running it up. My apologies. To check it. It's kind of interesting. See, you can't go down once you've gone up. So let me just show you a little code snippet here that's useful. So you go to runtime. Um, I wanted to restart. Well, I can just run before. Run before is a nice one. And so what that does is it just runs all the code before. Okay. And so because I've loaded the data then and I'm going through these steps in order, now when I get to this new line of code, which should work fine for you all, um, it's going to run the 50 estimators on top of the 25, meaning just 25 more is all it's doing. Okay. Um, may not be convinced because it took 2 seconds, but let's try it now. Not with let's go up by intervals of 50. Okay. So if you put in then this is actually the code we want. Copy this code. Okay. And what you're gonna put in here instead of in estimators is 50 is 100. Okay. Press shift enter. See what it takes. It took 4 seconds. Okay. Get the warm start equals true. It did. Some, I'm just going to do this runtime. Sometimes if you don't restart it, it can be a little fishy. So I'm just going to do this restart and run all. Because my expectation, which I did have before, is that the times should not be doubling, which I see on the left. They should actually be a little more consistent. Now, if I start with 25, right, that's going to be faster. See how now they match. These two both took 1 second. Okay. Now this one took 3. However, I did an addition of 50. Okay. So I'm going up by intervals of 50. And so let's just do this a couple more times. I'm going to go ahead and now change it to 150. Let's see how long that takes. So it should take about 3 seconds again because it's really only 50 new ones. It takes 4. It could take a little longer because you're having to add more. And now, and you don't have to do new coding cells for this, but we'll do one more. Let's do 200. Now before when we did 200, it took quite a bit. So let's see what it takes now. Just adding 50 more to the warm score. I'm expecting between 4 and 5 seconds, so it took 4 seconds. And I think I erased the code, but it did take longer. And to verify that, we can just redo this, okay? And I can start at say start at 200, right? So because I'm initializing here, I'm not using the set params. This is going to start with 200, okay? And so let's see, it should take definitely longer. And we're getting into a new theme here that we're going to keep looking at, which is the timing that it takes to build models. So warm start in effect, see 11 seconds. Warm start in effect is a great way to shorten the time of your model build when you're varying in estimators. Now, before leaving it behind, look, this copy and pasting code is nonsense. You want to use code to avoid that. And so I want to just do two things. I want to do a loop and a plot. Okay. I want to loop through and we're going to plot in estimators. All right. So you see, hopefully, from the code how to loop through. Just make a note here of what this means. Build, like this is building 200 decision trees from scratch. It takes longer. That's the point of this, okay? That's why I did this code. And then what we're doing here each time, just to compare, say this one, with warm start, only 50 decision trees are added. Okay, because it's keeping the scores on the first 150, right? That's the whole idea. And of course, same thing here. Add 50 trees. And it's set it right to the top. Okay, so now what we're going to do is we're going to do a plot. All right. So let's make a plot of n-estimators using 50 trees at a time. Okay. And so we can copy now, you know, in this loop, we'll copy some of the code. So first thing we want to do is initialize it. Okay. And we want to score it. We're going to get our first score in here. Well, the initializing is kind of like the thing that you only do once, right? So we're going to initialize the model. And we're going to start with 50. Okay. I like to just do the whole thing because it's a little bit clearer, I think, and then you loop through. So I'm going to collect the scores now. Okay. All right. So maybe I'll write this in. Initialize model. This raw is, we know what fit model is doing, fitting it to the data. Now, when you do the score, so before getting the scores, we want to set up list of scores. So we're going to plot them. And so if you write that out initially, there's nothing in it, right? But now, right after the first one, you can then put it in there. Okay. And this is where, honestly, because I see like with the, maybe let's put this initializing up here. So we have our two initial pieces, not in the n-estimators. Sorry, in the random forest classifier, but right after it. And when we do the loop, you know, I guess, see, I don't want to write this multiple times. That's what I'm thinking here. So let's look at the code that's going to go inside the loop. It's what we've been doing. It's this, right? We set the parameters and then we score it. Okay. So I haven't fit it yet. Okay. So may have like one line of repetition here, but let's now just loop through. So for I, say in range, we can start at 50. Now, if we want to go up to like, let's pick a number, I don't know, like 400 maybe 500, and then you would go to 501 and then go up by 50. Okay, that should work. And to test, no, you can always test your code, right? If you don't want to be stuck having something that like, you know, just doing way too much. So we can just do a quick print I. Does this give me what I think it does? Yes, it does. It gives me, note it's going up by 50 each time from 50 to 500. Okay, so this was just a check. Check range of 50 intervals for plot. Okay, yeah, I'll leave it in there. Okay, so now all we do, right, is we put these in the loop. Okay, and it's going to be I here, right? We're starting with 50, and then we fit it to the data and we get our score. And importantly, we want to append the score, right? So if I call this score, then I want to add that score to the OOB scores. Okay, and see how that works? We're just, each score that comes through, we're going to just put it in this list. Okay, so what we're doing here, loop through 50 trees at a time. I try to be consistent with my capitals. I think if I'm starting lower, let's keep it lower. Set in estimators. Fit on data. get OOB score. Add OOB score to list. Okay, just adding a little explanation there. So that basically will give us a full list, okay? This will give us the list of scores. All that's left now is to plot them. Okay, so we're now be outside of the loop. And plotting them, you could do that in different ways. Let's see, let's do probably import matplotlib.pyplot as plt. In effect, you can just do a plt plot. But we need to actually keep track of the number of trees too. Okay, so we need two things. We need the number of trees in addition to the OOB scores. What I mean is this: you have a list, but it doesn't tell us how many trees there are. I mean, it's not hard to do because each one is like a multiple of 50. So you could do it in different ways, but it seems simply I, right, should be our, I think we also want a list of number of trees. This is solely for plotting. So set up list of number of trees, and then you might want to call it number of trees. And then we just need to add it to the list too. Like, you know, add number of trees here. I just say add I. So same thing, we've got number of trees dot append I. So now when I do the plotting, I have a clear X and Y. Okay, so let's say X equals number of trees, which is a list 50, 100, 150, and so on. And then I've got the Y is the OOB scores. So it's going to tell me how good the scores are for each one. And let's see, do I want to add anything else? I mean, I know what it is, but you know, the main thing you want to do is plot it, right? So it's plt.plot x comma y. And make it a little bigger, maybe change the figure size. I'm just going to call this setup graph. So plt.figure, fig size, let's go with my screen, maybe, I don't know. And I'll go with 8 by, maybe the plot should be different because I might want to change it. I'm going to do this separate. The other thing is I can write it while the code is running because it's going to take some time, right? So quickly, what does this code do? Make a plot. So maybe I'll change this. Yeah, I mean, it's make a plot. Like, how about record 50 trees at a time for plotting? Okay, we have the initial model. Importantly, it's got the warm start equals true. Okay, and estimators, I guess you don't really need that here. The reason why is because we're going to loop through. We're going to get our scores all in a list and the number of trees in a list for plotting. Now I do the loop. This starts at 50, goes up to 501 so that we can get 500, otherwise it would exclude it. It's going to do 50 trees at a time. This is the important line. By setting the parameters in estimators equals I, when you do that 500 trees, that would take a really long time. It's just going to be 50 more trees. Okay, so in effect, this is like building 500 because it's just going to do 50 at a time. And then you've got to fit that in the data to get the score here. And we just add the score to the list and the number of trees. So let's see if that code works. And I'll go paste my previous code in here first. Okay, shift enter, got an error. As you can see, when they say invalid syntax, like if you look at it, that doesn't look right, meaning there should be an equal sign there. And that's a standard, like to get, you know, you put a chunk. See, I don't do this often for good reason. When you put up a bunch of code, you're more likely to have to sort through and find the errors. When you put up a little bit of code at a time, if it doesn't work, then it's easier to figure out the errors. Okay, it is building, right? See, it's fitting to the data. Okay. All right. Let's now check. Oh, this is, I should not call this Y probably. Did I call anything else X and Y? I don't want to reset Y here. I think we could just call it, instead of doing it like number of trees is X, let's just put that here. And Y is the OOB scores. That's where it's important to name things in ways that make sense. Okay, I'm glad I've caught that. So let's just take a moment to then make this graph maybe a little better. I didn't finish the figure size, so it's horizontal by vertical. So maybe for my screening is blown up a lot. Maybe that's just 8 by 6. Did I get an error? No, it worked. 50 seconds. I thought I saw an error. We'll find out soon when we try to plot it. And you know, you can put things like a title in here. So what's the title? plt.title. Got me a random forest warm start. Good. And what else? plt.x label. Say what it is. Number of trees, right? And plt.y label. Right, without the label, we don't know what it is. It's the OOB score. I want to say it's like hold one back, but why would it be OOB then? It's not hold one back. We're gonna look it up. Does that work? plt.show. See a little error here. Okay, let's try this. And there you go. Look at that. Pretty cool, right? So I'm gonna make what, my 8 by 6 horizontal. Oh wait, now I'm confused. I just think horizontal, vertical. Try that again. Yeah, I want to get it a little better so you can see it all. Okay, so what does this reveal to us? It's really interesting actually. So you can see it's, you know, the ranges aren't too big. Like it's like look at this. It's only going from like 85.25 to 85.6. So it's hardly mattering, right? Like more trees are not really helping here. Now, what's interesting though is you can see how it does change. It does seem to kind of clearly get better, but it looks like after 250 trees, you know, it dips. Sure, it comes back up, but it's not really significant, right? You don't want to spend twice as many trees here. And this is a really valuable tool. It's not just the warm start, it's actually the plotting. And you can use this general code here to create plots to get comparisons of changes in code and changes to the scores, right? You can score them. This could be the number of trees. It could be a hyperparameter. This is a hyperparameter in estimators, but it could be another one. Okay? So that's some pretty cool stuff about random forest.